Hello everyone, so in this video we want to determine which of the following isomers with the molecular formula of C₂H₂F₂ does not have a dipole moment. So the ability of an atom to attract the shared pair of electrons towards itself is called its electronegativity. So dipole moments occur in bonds as a result of differences in these electronegativities of the bonded atoms. The difference in electronegativity results in the separation of charge, creating what we call a dipole moment. The dipole moment of a bond is defined as the product of the magnitude of the charge and the distance between the charges. The charge is affected by the electronegativity difference between the two atoms. Our dipole moment of molecules is based on the magnitude and direction of each individual dipole bond. So in our carbon, the bond dipoles of the two FC bonds cancel each other out. So we're talking about our structure C here. We see that the bonds of our hydrogen and fluorine here, they do cancel each other out. So comparing our fluorine to our carbon here, there's going to be a pull towards our fluorine. Same thing for the other side of our molecule. So we're saying that these will kind of just cancel each other out. Thus, the resultant dipole moment of the molecule is going to be 0. We see here for our structure A, this option is actually incorrect because our fluorine actually likes to only have one bond and 3 lone pairs. And we can also see for the dipoles, it does have the same effect. However, because of this double bound here, it results in an incorrect structure. So that's why we eliminate option A. For options B and D here, they have non-zero dipole moments, meaning that there is a net dipole moment. So same thing, we go ahead and draw those dipole arrows. We already know that fluorine is more electronegative, so we can draw the arrow pulling towards the fluorine atom. Same thing for this here. If we sort of add or consider these dipole arrows as vectors, if we do a vector addition, they're going to have a net dipole of just being overall towards the fluorines. So we have a big dipole arrow going up like so. Now for option D, again, we draw out these structures. We can go ahead and draw the dipole arrows pointing towards the fluorine atoms. When we add those two vectors up, we can see we have a net dipole going towards the right side. So that's why we have eliminated options B and D. Again, for option A, it's the incorrect structure. For B and D, they do have a non-zero dipole moment. So the only correct answer that we have seen in this problem is going to be option C. So option C is going to be my final answer in this problem.